Okay, here's a video regarding section 3.2 part 2 on logarithmic functions. It's pretty much a review of what we did earlier in this section. So we focus on the left panel. We do see two graphs, y equals b to the x and y equals log base b to the x. Remember that a log is an inverse of an exponential function, and when you do have inverses, they're reflections about y equals x, that linear line or that function you see kind of going right through the middle. For a log function, or the red curve, the domain will be from 0 to infinity. So remember, the range for exponential functions was from 0 to infinity, so the domain and range switch. We do inverses. And so in this case, the range will be all real numbers for the logarithmic function. Instead of a horizontal asymptote, we have a vertical asymptote, x equals 0. There's no symmetry whatsoever. Log functions will be increasing. There are no extreme values. And as x approaches infinity, then y will approach infinity, as we kind of see that. It increases slowly, but it does increase. So if we take a look at log base b of 1, that's going to equal 0, because b to the 0 always equals 1. And log base b of b is 1. Whenever the base and whatever you're logging are the same, that's always going to be 1. So for example, if you have log base 5 of 5, of course that equals 1, because 5 equals 5 to the 1 power. Again, remember, exponential and log functions are inverses. So when you plug in the inverse into the original, or vice versa, you'll always equal x. So for example, square of x squared will be x, assuming x is greater than 0. Or if you subtract something with itself, or add, addition, subtraction inverses, multiplication, division inverses. So basically, these undo each other. It's almost like they cancel out in a way. Also remember, if you're logging the same thing, x and y will be the same if you have the same base. So look at some of these examples here. Does look a little nasty, but don't overthink it. So when those are the same, you get -8. And when those are the same, you get. Also, when these are the same, those expressions will be the same. And when these bases are the same, also those expressions will be the same. Go ahead and pause the video and try to work out A and B, and then we'll discuss. Okay, you should get x equals 8. Over here, you get x squared minus 3x plus 2 equals 0. Factor, you get x minus 1, x minus 2, x equals 1 or 2. Now, you do need to check your work because not all these answers will work sometimes. Like if you plug 2 in, that's okay, so you get 4 minus 2, 4 minus 2, that's good. But 1 won't work because what's going to happen is you get 1 squared minus 1, which is 0. And you can't log 0. Log base 3 is 0. I got no idea, because 3 to some power can't equal 0. So you can only log positive numbers. Keep that in mind. That will play a role in example 3. And going back to example 1 again, sorry, someone was at the door. Going to example 1 again. Whenever the base of your power and the base of your log are the same, they will cancel and you just get the expression that you're logging. Or in this case, if you put an exponential expression to a log, the base of the log and the base of the power cancel, and again, whatever the exponent is, that's what it equals. So kind of in line with what we saw for the inverses over here. So again, we can only log positive numbers. So when you're asked to find the domain algebraically, basically you need to make sure the expression you're logging is positive. So x is greater than -3, so interval notation, you get this. 2x minus 10 is greater than 5. 2x is greater than 0. 2x is greater than 10, x is greater than 5 to infinity. You might be familiar with common logs. So whenever you don't see a base, you always assume it's 10. So setting that equal to y, and remember, log base bx equals y, the same thing as x equals b to y. So 100 equals 10 to the y power to y equals 2. Ln is log base e, so just remember that. And remember, e is just roughly a number, it's like 2.7. So when you see ln e, that's log base e of e. So e to equals e to that. So of course, that's just going to be 1. But in this case, this is not possible. Remember, you can't log negative numbers. It's like saying log base e of negative 2 equals y, negative 2 equals e to the y. No good. Can't do it. Okay, we keep moving. Properties of natural logs. So just the same as any log. Don't overthink it. Y equals e to the x behaves like y equals 2 to the x, 3 to the x. It just means that e is roughly 2.7, so your base is 2.7. In fact, you got pointer at 0, 1. You got pointer at 1, 2.7. Here you have a point 1, 0. Here we have a point 2.7, 1. The ln1 is still 0, ln e is still 0 because that's log base e of e. Here you're putting e to the x into log base e, so the e's cancel, you just get x. Or here it's e log base e, the x's cancel, and that's log base e of 1. So, don't overthink it. Same thing as any log. So when you have something like this here, that's log base e of e to negative 2. Remember, 1 over e squared is e to negative 2, so you get negative 2. Log base e of e pi, just pi. It's like those cancel, right? These expressions have to be the same. X minus 4 equals 2, x equals 6, x squared minus x equals 6, x squared minus x minus 6 equals 0, x minus 3, x equals 2. Of course, x equals 3 or negative 2. And negative 2 actually would be okay because you would have 4 minus negative 2 and it'd be okay. So you just you can't log an expression that's, or a number that's negative, but when you plug negative 2 into the expression, you're fine. Going back to actually the extraneous solution we had for example 2, part B, if you were to graph this as y1, the graph this is y2, and actually take a look at the graphs, you're going to find that they only touch once. They wouldn't touch at 1, so I guess that's why you also only have one answer. And 1 we say is an extraneous solution. Let me write that out more cleanly. Last, we have a word problem. If you take a look at the word problem, they have all this noise here in the beginning, but really all they want is the temperature change at 50. You just plug in 50 for x. Work it out. And you should get something that's close to 41. I think it's at 40.8, I can't remember. Pretty easy. Just remember ln and log are the left panel of the graphic calculator, or you can actually go to Desmos, use the scientific mode, and access log or ln that way. Or you can also do a change of base if you want a different base besides common log or log base e. Okay, that wraps up the video.